All right, so we left off on Module 11, practice problem number 3. So this is where we're going to start, okay? So it says, the following reaction is performed in a lab, and then it gives you this equation right here, okay? And then they say if 345 milliliters of 1.25 molarity aluminum nitrate is added to an excess of sodium sulfate, how many grams of aluminum sulfate will be produced, okay? So these are the type of problems where we're going to take our molarity equation and we're going to use it with stoichiometry, okay? These next 3, 4, and 5. So we always want to know, what are we trying to find out and what do we know? So let's figure out what we need to find out. They said how many grams of aluminum sulfate will be produced. So I'm going to underline that. That's my aluminum sulfate. I'm going to put grams, question mark. That's my end goal, okay? So I know I need to get over there. Let's see what they gave us, what information they gave us. And they said you have 100 grams of silver bromide, oops, wrong one, 345 milliliters, and 1.25 molarity of aluminum nitrate, okay? So that's this guy. So I know I've got information here. So I'm going to go ahead and do my arrows. I know I need to get over here from here, okay? Which means we're going to be using moles. So I know ultimately I need moles of this, so I can get over to moles of this and then get to grams, okay? So my first goal is moles of this. So I'm going to take the information they gave me and I'm going to find moles, okay? They gave me a volume and a molarity. So I've got liters and molarity, so that's going to give me number of moles. So I'm going to use equation number 2 right here, okay? So number of moles is equal to, I'm going to stick my molarity in there, 1.25. Remember, molarity is just moles over liters, okay? So it's really just moles over 1 liter, okay? Now I'm going to be multiplying that by the number of liters. They gave me 345. I'm going to change it into liters. We don't want milliliters, okay? So that's what it would be in liters over 1, okay? So I'm going to go ahead and crunch this through my calculator, and I end up with 0.431 moles, okay? So that's moles of this. Now I've got moles of this, I can go to moles of this. So this is where our stoichiometry is going to enter. So let's start here. 0.431 moles of AlNO3, put it over 1. And we're going to take moles and we're going to use our coefficients. So I have moles of this guy, AlNO3, and I want to get to moles of this guy, moles of Al2SO4, 3. So I'm going to use my coefficients. I've got a 2 here and a 1 here, okay? When I crunch those numbers through, I'm going to get 0.216. 0.216 moles of Al2SO4, 3. So now all I have to do is go from moles to grams, okay? So I'm going to put this over 1. I know 1 mole of this is going to be equal to grams of this as well, Al2SO4, 3. So all I need to do is figure out my grams here. So I'm going to take my periodic table and I'm going to figure out how many AMUs are for each one. I'm not going to do that right now. I'm just going to plug my number in because I already figured it out. It's 342.3 grams. So if I crunch this last equation and I use my significant figures, I should end up with 73.9 grams of this, okay? So that should be your answer. So I really just use my molarity equations and then I use stoichiometry for the rest of it. All right, so let's erase that one and we will work on the next one. Equation 4. All right, so I have these behind here. Let's just move this up a bit. Try to save some time. Okay, so let's look at number 4. This marker works a little bit better. Number 4 says, aqueous Sodium bromide and silver nitrate will react to form solid silver bromide, a compound used in photography, and sodium nitrate. And then they give you this equation right here. Okay? It says if a chemist needs to produce 100 grams of silver bromide, how many liters of 2.5 molarity silver nitrate must be added to an excess of sodium bromide? All right, again, same type of problem. So we need to figure out what do we need to figure out, what's our end goal, and what do we know. So they said it says how many liters of silver nitrate, okay? So that's going to be this guy. I'm looking for liters. So I'm going to put a liters question mark. And then I need to know, what did they give me information about? They gave me 100 grams of silver bromide, which is this guy, okay? So I'm going to go ahead and put my arrow so I know where I'm going. I know I need to have moles of here to get to moles of this so that I can get to liters. Okay, so this is my first end goal, moles of this, so I can move over. So I'm going to go ahead and take my 100 grams. That's what they gave me, 100.0 grams of AgBr. Put it over 1, and now I need to turn that into moles. So I know 1 mole of this. Okay. Now I just need to figure out what goes here. So I go up to my periodic table, I find Ag and Br, add them together, and that's going to be 187.8. So crunch this through, and you end up with 0.5325 moles of AgBr. Okay? So now I've got moles here. I need to go over to moles here. So I'm going to take that 0.5325 moles of AgBr and moles. I'm going over to here, AgNO3, AgBr. Okay, so I set it up. I just need to put in my coefficients. So this one is a 1 and this one is a 1, which is nice. I'm going to end up with the same number right there. Okay, 0.5325 moles. Now, I've got moles of this. I need to get to liters. So I go up here and I see what I have, okay? I have moles and I need to get to liters. So I'm going to go ahead and say, here's my equation, moles, capital M, capital L. If I want to get liters by itself, oops, I'm just going to do a little bit of algebra to move that equation around. So it looks like I'm going to put my moles over my molarity, okay? So my number of moles, 0.5325 moles over my molarity. And they gave that, it is 2.5 moles. 2.5, remember molarity is moles over liters, okay? This is going to give us liters because you can see your moles cancel. So I put this through my calculator and I end up with 0.21. My unit is liters, and this was of AgNO3, okay? So that's going to be your answer. So real quick, let's review. We started with the grams here and switched it to moles. We went moles to moles, and then we used our equation from up here, just shuffled things around to find liters of that, okay? So let's erase and do the last one. All right. Move this over. Move this over. Stay there. And lastly, move this over to the side there. Okay, so this is our last equation. Let's stick this up here. This is our last equation for number 5. And it says, one popular test for lead, Pb2, contamination in drinking water is the chloride test. This test involves adding NaCl to water. Any Pb2 in the water will immediately react with the chloride, forming a solid precipitate. So they give you this equation right here. And then they say, measuring the mass of this precipitate can tell you what the concentration of Pb2 is in the water. If an excess of NaCl is added to 1.6 liters of water and 25 grams of PbCl2 are produced, what is the molarity of that lead in the water? So remember, we need to figure out what do we need to find out and what do we know, okay? So going to our equation, they said, what is the molarity of Pb2 in water? That's my end game. I'm going to underline it and put a capital M. That's what I need to know. And then I see, what did they give me? Okay, so they gave me grams of PbCl2 right here. So I know I'm going to use moles of this guy to get over to here with moles, and then I can figure out the molarity. So let's start with what they gave us. They gave us 25.0 grams of PbCl2. So we want to change it to moles. Okay, 1 mole of this is equal to, and I'm just going to go to my periodic table, find Pb, find chlorine, add them together, and if I do that, it's going to be 278.2 grams. So if I crunch this through, I'm going to end up with 0.0899 moles. Okay, so now I'm going to find mole. I'm going to use my moles of this that I just found, switch over to moles of this. Okay, 0.0899 moles of this PbCl2 over 1, and I'm going to do Pb on the top, moles of this. Okay, so I look at my coefficients, it's a 1-to-1 ratio, so I'm going to end up with my same number for moles of this. Now, if I'm finding the molarity, just like I did with the last one, I'm going to use my number of moles, and I'm going to just rearrange my equation, okay? So I've got molarity equals number of moles over number of liters. And did they give me liters? They did. They gave me liters. So this should be a pretty easy problem, okay? So if we're finding molarity, I'm going to stick my number in, 0.0899 moles of Pb over, and they said 1.6 liters of water, okay? So crunch this through, you're going to end up with 0.056, and remember, moles over liter just means molarity. That's your capital M. So your answer is going to look like that, okay? So just to review, we took the grams of this, went to moles, went moles to moles, and then we used the moles here in our equation to find our missing piece, our molarity.